Okay, and so far you know that we could represent or identify points on a plane in Cartesian coordinates by two numbers. One of them is the distance of the point from the y-axis, and another one is the distance of the point, which is called the x-coordinate, and another one is the distance from the x-axis, which is called the y-coordinate. Okay, but there are another ways to represent or identify the points on a plane, and here I want to talk about the polar coordinates. What is polar coordinates? It is identifying or representing the points on a plane instead of by x and y by the distance of the point from the origin r and the angle this, and the origin here calls the pole, we call it pole. Okay, and another coordinate is the angle, this angle. Okay, we should show it by theta. And for a each point got a distance from the origin or the pole. Okay, but how many of points got the same distance from the origin, the same distance r, say, or r0 from the origin? The answer is infinity, and this is the point on the circle which radius is r. Okay, but in order to represent a single one of them, we should, they differ, the r coordinate of all of them is the same, but the theta coordinate of them is not. For instance, this point, the theta of this point is this. The theta of this point is this angle. Okay? Now, why do we need the polar coordinate? The answer is that sometimes it's better we work with the distance of the points from the origin. For instance, one of them is when we have a central force. For instance, let's say in our solar system, this is the sun, okay, and the planets are around the sun. And say this is the Earth, and the sun applying a gravity force to the earth, which depends on the distance, okay, and also force got a direction. As you may know, that force is a vector, and instead of the magnitude, it got a direction. And here the force, the magnitude of the gravity force, the sun applying on the earth, depends on r, and its direction is in this direction, okay? So it's better we work with the polar coordinates instead of the usual Cartesian coordinates, because in Cartesian coordinates you should write the force, the force as the x coordinate of the force and the y coordinate of the force. And you should add or subtract the force by the vector rules. It's not the force is here. And it is kind of nonsense. So it's better to work with the polar coordinate. And we should also, in order to calculate the velocity and the acceleration, we should write it as for instance, the acceleration in the x direction plus the acceleration in the y direction. Also for the velocity, which is not necessary, because the force acting this way, in this direction. Why should we care about the x and y directions? Okay, another reason that we use the polar coordinates instead of Cartesian coordinates is that in many of useful cases, the expression is way simpler. For instance, let me draw another coordinates here. For instance, take this circle, which radius is 1, and the origin is its center. Here in the Cartesian coordinates, the equation of the circle is x squared plus y squared is 1. Or if we write y in terms of x, that would be plus or minus 1, the square root of 1 minus x squared. But in Cartesian, in the polar coordinate, its equation would be just r equals to 1. Instead of this, we got this. The points on the circle, their distance from the origin is 1, r equals to 1. And before having more examples, let's first talk about how to transfer the both coordinates into each other. Okay, this is R. So here, this is X, this is Y. Here in this right triangle, we got cosine of theta. Cosine of theta is X over R, and sine of theta is Y over R. Or we know here X would be R cosine theta, and Y would be R sine theta. You know, for instance, in the circle, which equation was this? In order to transfer it to the polar coordinate, just substitute these two. So X is R cosine squared, we got this, plus, and Y is this, we got R squared sine squared is 1. And this is R squared times cosine squared plus sine squared equals to 1, and this is 1 inside the parentheses. Then R squared would be 1, or R would be plus and minus 1. And you know, in the polar coordinates, the R is always positive, so R is 1. So let's have more examples of how polar coordinate, the equations of the curve would be simpler.